Okay, for practice 1, we are going to go through and determine where the table of value represents a function and go ahead and write it, and then write the linear function. So what we need to do is first see if from one y to the next, if it's consistent, if it's constant, and then also make sure we check the x's as well. So from 5 2/3 to 5. So what I would be doing is, like we did in our differences, is doing a subtraction. Now you can also tell from 5 2/3 to 5 that you're changing, you're going down, you're decreasing by a value of 2/3. Now after that, from 5 to 4 1/3, just depends on how good with your fractions. But otherwise, you can go to your calculator, you are changing by 2/3, you are changing by 2/3. So far, so good. Now on the x's, from -2 to 0, when we went from -2 to 0, we increased by 2, as everything else plus 2. 0 to 2, 2 to 4, and that checks out. So because of that, we are going to say we are linear. And all of a sudden then, we've just calculated our slope as well. Now our slope in this problem is, again, where it's going to be nice maybe to have your calculator, -2/3 over 2. It's the change in the y's over the change in the x's. It's just in our notes, we didn't do a fraction divided by 2. So in that case, here's a new one, okay? Now, -2/3 divided by 2, if you got your calculator, you punch it in, you're more likely going to get on your calculator a repeating decimal. You're going to get -0.3 repeating, which that implies then is -1/3 is your slope. Now from there, we have half of our linear function's equation. Remember, we're trying to create something that looks like this here. Now we've got the slope, which is -1/3. But the thing that we are also missing then is that y-intercept. Remember, the y-intercept occurs when x is 0. And when I look at my x values, I'm looking for x to be 0. And luckily on this one, I do have x as 0, 0, 5. So on this one, they gave us the y-intercept at 5. So there is my equation then for that. Number 2, I'm going to do the same thing. -27 to -2, -2 to 20. Is it changing by the same amount? So what I would be doing in my head is, we're increasing by a change of 25. Now, that's 25 from -2 to 20. We continue to increase. This is a changing by 22. 20 to 48 is 28. And as soon as I see the y's right there are not changing consistently, I can be done. On the x's, if I did check that for any reason, we're increasing by 5. We're increasing by 5. Write that better. Now the x's are cool, but because the y's are not, this is what we're going to say it's not linear. You cannot calculate the slope. You cannot write the equation. Okay, review 1A. Basically, it is the exact same thing. So 9 to 11, 11 to 13, 13 to 15. On the x's, 2 to 3, 3 to 4, 4 to 5. There we go. It is linear. It's consistent on the y's, consistent on the x's, and therefore my slope is the change in the y over change in the x. Now, as we did on the other page, we're going to do right here. I want to create an equation based off of that. And I calculated the slope as 2, as we've been doing. I don't have a lot of room here, so I'm going to just move it up top. Now, the y-intercept on this one, I unfortunately do not have very easily. Right here, I want to see when x is 0, but I don't have that. So what I want to do is kind of work this backwards and add that into my table. So I'm changing by 2 from each one to the next. So to go backwards, okay, I'm at 2 and I want to get to 0, so I need to go 1, I need to go to then 0. So if I'm going backwards by 2, it'd be 1, 7, and then 0, 5, okay? So on that one, the y-intercept then turns to be at 0, 5. So that completes my equation of 2x plus 5. And then 2a, are they positive and negative or no association? And my eyes appear to be going up, all right, and they appear to then have a positive association, okay? That will do it.